Hello everyone, greetings to all of us. Before I start my presentation, I want to say thank you very much for having me here today, and also the committee for making such a wonderful event. It's a great honor to be presented in this top international conference. The topic that I will bring up is structure modeling and analysis for improving the strength of horizontal pump system. Okay, for the outlines, introduction, method, results, and conclusion. We all know a pump is a machine that is widely used in industry, especially in the petroleum industry. The pump function is to move the fluid from one place to another through the piping medium by adding energy. This research is motivated by the problem appearing of load increase at the suction and discharge nozzle, so that it exceeds the allowable load. That load surges cause the pump structure to receive large vibrations, which results in damage to some horizontal pumping system structures. Vibration is caused by a pump failure in the transfer of fluid, which is oil. If the damage is found in one of the pump holders, cradle and base, in horizontal pumping system, it will cause damage to other pump parts, so that a shutdown can occur. The purpose of this research is to analyze the structural strength and structure development of the horizontal pumping system. The SolidWorks application is used to draw 3D models and ANSYS static structural as computation in analyzing the horizontal pumping system structure. The goals of the research are to find out how much is the displacement and the stress on the pump. If large displacement and/or distress exceeds the yield strength of the material occurs, then it is necessary to develop the horizontal pumping system structure. Okay, for the method, geometry and material of the horizontal pumping system are obtained based on the on-site measurement. The materials we use in the horizontal pumping system in this research can be seen in the following table. For the numeric equations, the structural analysis method use equilibrium stress-strain equation and Young's modulus. In general, this requires the equation of force and moment of equilibrium along the three independent axes shown by the left equations. And for the right equation is for loads that are still in the elastic region. The relation between stress and strain is stated by derived Hooke's law. Next, for the analysis procedure was performed using ANSYS static structural software. In the study, a structural analysis was carried out and the results show how much displacement and stress on the pump was. Load and moment data on the suction and discharge nozzles are entered as input parameters of the horizontal pumping system boundary conditions. And also the bolt pretensioning is entered as the input parameter to maintain the pump position. The bolt pretensioning is assumed to be 75% of the ideal. The following table is show amount of the bolt pretensioning used in this research. Besides, fixed support is assumed to be at the base of the pump as load support and a barrier to the pump movement so that it doesn't experience a displacement. And for the mesh generation is carried out using ANSYS static structural as shown in the figure. The mesh generation uses a fine meshing to obtain mesh convergence. Triangular meshing is considered because it matches the geometry and material characteristic of the pump. So the horizontal pumping system is distributed to 275,033 elements, which contain 528,040 nodes. The average skewness of the mesh has a value of 0.34926. For the validation in this study, the results of research by Sung-Hyun Lee et al. Conducted in 2020 were used. One of the methods used in this research is static load analysis. The results of Song-Hyun Lee's research were in the form of displacement and stress on the primary heat transfer system pump parts and looking for the parts that experience the greatest stress. The results of the validation using the program can be seen in the following table. From the following table, it appears that the difference that occur in the displacement and stress analysis between the results obtained in the study and Lee et al. Small enough, so that the results of the analysis in the study can be accepted. Furthermore, based on the following figure, it can be seen how much displacement is in each part of the pump. For the results, the first result is displacement in the horizontal pumping system structure. We can see the increase in the load of the horizontal pumping system causes stress strain on the pump, so that there is displacement in several pump parts. Based on the following figure, it is found that the largest displacement occurs in the horizontal pumping system located on the side of the pump, which is connected to the suction nozzle. Very large displacement occurs because the load increase exceeds the allowable load on the horizontal pumping system structure. The amount of displacement at its nozzle can be seen in the following table. Based on the results, it was found that the suction nozzle had a very large displacement, so it was necessary to make improvements to the side of the pump that was close to the suction nozzle. For the next result is stress on the horizontal pumping system structure. Based on the results of the structural analysis, it was found that the greatest stress was found on the middle side of the horizontal pumping system. This stress is caused by an increase in the load on the suction nozzle and discharge nozzle of the horizontal pumping system. This stress is and on the right, the stress of its cradle in the horizontal pumping system can be seen in the following figure 2. The increase in load on the suction nozzle and discharge nozzle causes the cradle to stretch and tighten. After knowing the amount of stress in its cradle, it is necessary to analyze the strength of the cradle by comparing stress received by the yield strength of the cradle material. The greatest stress is experienced at cradle V because cradle V is the center of support for all cradles. It can be concluded that the cradle is still in the elastic zone, so it is still safe to use and does not require improvement. And this additional cradle creation is our improvement. An additional cradle is made to maintain the position of the pump to prevent displacement. The additional cradle position will be placed in the part of the pump that is connected to the suction nozzle. The material used in this cradle is a solid rod fabricated in a circular shape with galvanized steel material as seen in the following figure. After the improvement of the horizontal pumping system by adding a cradle on the side of the pump associated with the suction nozzle, the results are shown in the following figure, which is on your right. On the right, the results of the comparison of change in the amount of displacement can be seen in the following table. Displacement change occur because of the center of displacement force that is held by the cradle, so the displacement on the pump can be minimized. On the following table, you can see the before and after amount of displacement. Okay, next. For the conclusion, we can say for the first, the largest displacement before the improvement is located on the pump side associated with the suction nozzle, which is the amount that you can see. And secondly, after the improvement, there was a significant change in the pump displacement, and you can see in your screen too. And the third conclusion, the additional cradle can reduce the amount of displacement at the pump. And here are references. Okay, that's all my presentation. hope you all enjoy my presentation, and uh, thank you for your attention, and see you.